Hello scholars, today is April 22nd, Wednesday night. Happy Earth Day. Yeah, in case you didn't know, it was supposed to be Happy Earth Day. So that's what I'm going to use. Earth color, green, blue, and turquoise. I don't know, whatever. This just reminds you. Oh, I need brown. Anyhow, I hope you guys are doing well. I enjoy outside weather today. Was able to go outside and just, get my vitamin intake of the day. It's supposed to be raining tomorrow. Tomorrow is Thursday, so hopefully while you guys are doing it, just stay inside. Well, you can still go outside and be crazy. Yeah, there it is. Today we're going to go over 2 questions from Skill 44 IP that most of you had a question about, and then do the skill lesson on Skill 45. And that will be it for today. All right, Skill 44, I'm going to go over number 8 and number 10. So those are 2 questions that most of you had a question about. So let's look at number 8. What I would like to do here is I'm just going to set it equal to x and then find out what x is from there. How I'm going to do it, I'm going to convert this to exponential form. So let's remember, how do we write an exponential form? Find your base. Base is that little number over here. So base is 2 raised to the, what's the exponent? X power equal to the argument 2 cube root of 2. Okay, so there's the exponential form. Now I'm just going to do the magic on the right side of the equation so that I have 2 to the something power. And then just let x be whatever that exponent is. Okay, over here, what it is here is that it's a 2 times cube root of 2. There are 2 things are multiplied together. When you don't see the exponent, what is the exponent over here? It's 2 to the first power. That means 2 to the first power times 2 to the, let's see, when it's a cube root, that 3 becomes the denominator of the exponent, right? So it becomes 1/3. The denominator 3. And then now let's combine these 2 together, multiply with the same base. That means we are adding the exponent. So what's 1 plus 1/3? That is 4/3. So what is your exponent? 4/3. Answer 4/3. Okay. All right, number 10. Same thing. I'm going to set it equal to x, convert to the exponential form. 6 to the x power equal to 6 times 6 to the half power. It's very similar to number 8, I see. 6 to the first power times 6 to the half power. Add your exponent. What's 1 plus half? 3/2. So your exponent is going to be 3/2. Cool? Okay, so those are 2 questions from Skill 44. Now let's go over Skill 45 lesson. Right. Oops. I know the notes you have, it just says Skill 45, so just get rid of that. Boop. Skill 45, properties of the logarithm. It's going to be the long lesson because there's just so many important things that I have to go over it, so hang tight. Hang tight? Is that expression? I don't know. Hang tight. Stay there. Don't move. Well, you can move. Alright, so consider the expression 1 plus 1 plus n to the n power. Complete the table below for given values of n. Usually we're going to use a calculator. If you're in a class, I spend like 10 minutes go over this, but I don't have time for that. So what it means is just plug 1 in instead of 1, n. So it's going to be 1 plus 1 over 1 to the 1 power, and then 1 plus 1 over 10 to the 10th power. So you're just plugging in those n for whatever that is. And when you do that, you plug in your calculator, you're going to notice that these answers become something closer to a certain number. Oops. Blah, 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 blah. And when n is a super big number, it's going to be 2.718282 and dot, 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 dot. So that number that this value is getting closer is called E, and it's called natural base. So 2.71828 dot 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 is called E, and it's called a natural base. You can find that value in your calculator as well. Where is it? Let's see. Find the E button. E button. Do you see the blue one right here? So if I do second E, hit enter, it says 2.7182881 blah blah blah. It's kind of like a pi, right? If I type pi, I know 3.1415, blah, blah, blah. How do I know it? Because I went over this so many times in middle school and high school, so I kind of memorize it. E is similar to pi in a way that it's a very important number. It's irrational number. As you can see, the decimals do not repeat. E is used a lot in math and in economy class. You guys know my trouble with that. It's very fun number. I don't have time to investigate, but a few fun things about E. When you're adding up all those factorial means you're multiplying that number underneath it. So it's 2 factorial means 2 times 1, 3 factorial means 3 times 2 times 1, and so on. So when you're adding all this number, it becomes E. Euler, smart mathematicians found that out. Euler. It's spelled Euler, but it's actually Euler. Another cool thing about calculus, once again, I can't go over it, but it's really cool number, E. So please remember, E is 2.7182 blah blah blah. It's called E, and it is also called a natural base. Cool? And it's also written as the following. Okay, so what if I have log base E of, I don't know, 32? Instead of writing that, I can write this as ln of 32. So when you see ln, you read it as a natural log and assume your base is going to be what? E. Okay? Ooh, quick question, quick quiz. What base do you assume when you don't see it for just the log expression? Hopefully you know it. What is it? Yes, 10. That's called a common log. And what is this called? Natural log. Okay? Log, no base, assume it's 10, common log. ln, you read it as a natural log, no base, you assume that as a E, and it's read as a natural log. Okay? Don't read it as a ln. I did it all through high school. No one fixed me. But college, I learned it's called natural log. Okay? All right, all the property of the log that exists for the base other than E also exists for the natural log. So all the property stays the same. So let's look at it over here. How do you read this expression, guys? Is it log 320? No. Log base 3 of 20. It says to find the value of log of the argument 20 over log of the base 3. I'm just plug it in. Let's plug it in my calculator. So log of 20 divided by log of 3. I got 2.727. On the right side, it also says to find, instead of a log, it asks me to find the natural log of the argument 20 over natural log of the base 3. I don't know. Let's see. Where's the natural log button? Just underneath the log button. So natural log of 20 divided by natural log of 3. Do you guys see that it's the same value? Yes, so that's what the note it means by that the property stays the same. So these are going to be the same thing. Whether you do the log of A over log of B, natural log of A over natural log of B. I don't have time for it. Well, let's just have fun. Well, whatever. I'm going to set it equal to x. This one actually we don't need a calculator. We can just do it by head. How do I convert to the exponential form if I want to find what x is? You should just always keep in mind, think about it. It's going to be 2 to the, what exponent gives me answer of 1 over 16, right? So 2 to the x power equal to 1 over 16. What do you notice? Well, it got reciprocalized. That's a negative exponent. And 2 to the what power gives me 16? How many times do you have to multiply 2 to get to 16? 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So answer, negative 4. And when you plug in your calculator, you're going to get negative 4. But whatever. Okay? And if you do natural log of 1 over 16 over natural log of 2 over here, I bet you're going to get negative 4 as well. So, what can you conclude about the value of log base B of A, log of A over log of B, and natural log of A over natural log of B? What can you conclude? They are all the same thing. Okay, So when I want to find out what this value is, I can plug it in my calculator, probably because calculator is the common log, the base with 10, or I can just plug it in as a natural log. Okay, so that's the takeaway you should have about the first page. Now that we know it, let's do some exercise problems here. Look at the first one. Find the value of x in each of the logarithm equation below by rewriting as an exponential equation. Okay, everyone, what's the base? 9. What's the exponent? Negative 2/3. What's the argument? X. So 9 to the that power equal to x. I write it as exponential form. Let's go ahead and solve it. How do I do it? Well, I see the negative exponent, so is it okay if I just go 1 over 9 to the 2/3 power? Right? Because 9, you reciprocal, it's a 1 over 9. Now, how am I going to find that value? I kind of touched that on Skill 44 lesson, but let's just review. First thing you need to do is rewrite 9 as the exponential form. Okay? 9 is what base to the what exponent? Well, 9 is a famous one. 3 square. Right? Okay. And then you have an exponent raised to the exponent, so I'm just going to multiply it. What's 2 times 2/3? 4/3. So that's enough. I think on my answer key it says 1 over 3, cube root of 3 as well. This would be fine if you write that like that on your quiz. Or if you want, you can do 1 over denominator of 3. That means the cube root of 3 to the 4th power. That's fine as well. Okay? All right, the second problem. Ooh, I don't see the base. What is the base here? Do you see it at natural log? Natural log has a base of e. So e to the 3rd power equal to x. How would I find what x is? Super simple. You literally plug in your calculator. E raised to the 3rd power, 20.086. Okay? Alright, third one. Where's the base? 3. Where's the exponent? Boop. Negative 3 equal to, argument, 2x plus 1. 3 to the negative 3rd power is 1 over 3 to the 3rd power, which is going to be 1 over, what's 3 times 3 times 3? 27 equal to 2x plus 1. This is like algebra 1 right there, although it kind of looks a little complicated. So let's go over it. How do I solve for x? Subtract 1, subtract 1. Okay, this is negative 1 plus 1 over 27, so I need a common denominator. Okay, what's common denominator between 27 and 1? 27. So I get negative 27 over negative 27 plus 1 over 27. I get negative 26 over 27 equal to 2x. Let's go ahead and keep solving for x. I just need 2 divided by 2, same as multiply by half. So I multiply by half, multiply by half. What is negative 26 over 27 times half? Boop, boop, 13. Negative 13 over 27 is my x there. Alright, this one, convert to the exponential form again. Base 25, exponent x is equal to 5 square root of 5. Convert to the same base. 25 is what? 5 squared. Over here, it's kind of similar to your IP that I went over, right? 5 to the 1st power times 5 to the square root becomes, that square root means it's a square root, right? That becomes the exponent, so it's going to be half. Now you can just add your exponents together. What's 1 plus half? 3 half. And then over here, you multiply your exponents. Now bases are the same. That means 2x is equal to 3 half. Divided by 2 or multiply by half. Boop, 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 boop. Answer, x is equal to 3. Okay, so all of them you just convert to the exponential form and then solve from there. Now, two exponential expressions can be multiplied only if their bases are the same. In that case, what is done with the exponent? So for example, guys, over here, their bases are the same, right? And you're multiplying it. What did you do with these two exponents? 1 and half. We added it, right? So that's where we're going to write it here. b to the x power times b to the y power equal to b to the x plus y power. When you're multiplying with the same base, we add the exponents together. Same thing with the division. When you're dividing with the same base, we subtract our exponents. Okay? All right, now pause. Pause. If I ask you what log base 3 of 9 is, what is that? This is what you should be thinking in your head. You should be like, okay, 3 to the what power? Just imagine right here. 3 to the what power gives me answer of 9? 3 to the second power, right? So answer is 2. So I need you to remember that logarithm expression is equal to the exponent, right? The whole logarithm expression is the exponent, 2. Okay? Keep that in mind. What is log base 3 of 9 again? 3 to the what power gives me 9? Second power. 3 to the what power gives me 3? First power. 3 to the what power gives me 27? Cube. What's 2 plus 1? 3. Are you still there? So, remember over here I said logarithm expression represent the exponent. When you're adding two exponents, right? Because we're adding two logarithm expression, that's same as adding two exponents. What happened over here? We multiply our arguments, 9 and 3, to get to 27. Once again, when you're adding two exponents, that's same as multiplying your arguments. 9 times 3 is 27. Argument is the answer of the exponential form. Okay, so make it easy. Log base, when you have a same base of log you're adding, that means you're multiplying your arguments. That's called power rule. No, product rule. And we'll get there next page. All right, 2 to the what power gives me 32? 2 to the 5 power gives me 32. 2 to the what power gives me 4? Second power. 2 to the what power gives me 8? Third power. What's 5 minus 2? 3. So now when you're subtracting two logarithm expression, what do you do with your arguments? 32 and 4, I divide it to get to 8. Right? So when you're dividing, that means you're subtracting exponent. When you're subtracting exponent, that means you're dividing arguments. Same. So these are same thing. Okay, now there are a bunch of properties that are very important. So let's go over that. First thing is called the product rule. And notice all of this exponential rule, if it works for the logarithm, it works for natural log, right? If it works for log, it works for ln, natural log. 1 second. So let's go. Log base b of m plus log base b of n. What's going to happen? Log base b of m times n. When you're adding to logarithm expression, that means you're multiplying your arguments together. Same thing, if it's a natural log of a plus natural log of b, that means natural log of a times b. That's a product rule. Number 2, quotient rule. When you're subtracting two logarithm expression, that means we are dividing the arguments. So log base b of m over n. The bases keep the same. It's going to be just m divided by n. Same over here, natural log of a over b. Now, let's do number 3. This one I'm actually going to kind of prove it to you. I'm going to let that equal to x. So let's say x is what we are trying to find. And I need you to go ahead and convert this to exponential form. Help me out. What's the base? B. What's the exponent? X equal to argument b to the n power. So what is x equal to then? X is equal to n. That means this whole thing is equal to n. N. Ta-da! Easy way of remembering this is that if the base of the logarithm expression and the base of the arguments are the same, you can cross it out and just left with n. Same thing over here, natural log. I know base is e, although you don't see, you know base is going to be e. So I can it's going to be n. Don't like cross it out, so because you still need to be able to see it. Okay. All right, number 4 is called the power rule. What happened here is that if the argument has the exponent, like this one, your argument is a to the n power and it has an exponent of n, what you can do is you can take that n and drop it in front of the logarithm. So it becomes n times log base b of a. Same thing over here, natural log, your argument is a to the n power can be dropped in the front, n times natural log of a. Number 5 is called the change of base. We did it in the front page. How would you plug this in your calculator? Log of a, the argument goes on top, over log of b. Base goes at the bottom, or you can just type it as a natural log of a over natural log of b. 99% of you will make, well, 99% of people who will make mistake of this property will like reverse it. So remember that argument goes on top and the base goes at the bottom. Change of base. Number 6 is the inverse property. So this is in exponential form, guys. Kind of like zoom out a little bit so you can see the big picture. And if it's an exponential form, you have a base and the exponent. What's your base? B. What's your exponent? Log base b of a. Notice that the base of the exponential form and base of the exponent are the same thing. That means you can cross it out and it just becomes the a. Same thing with the natural log. Boop, it just becomes the a. All of that. Super duper important. So let's go over the example. I think examples are more important. Well, properties are important, but you kind of have to see how it goes out. All right, notice over here, look at your argument. Your argument right now is x times square root of y. What does that mean? Well, that means it's x times square root of y. All right, if you remember over here, when your arguments are multiplied together, I can separate them with a plus in the middle, right? So I'm going to separate them. So natural log of x plus natural log of square root of y. Let's do one more. Natural log of x plus, guys, if I were to write that square root, it's going to be y to the what power? Half power, right? Yeah, that's square root denominator 2. There's one more thing we can do. What else can we do over here? If you remember number 4 power rule, if your argument has an exponent, you can drop that in the front. So that half can be dropped in front of that logarithm expression. So it's going to be half times natural log of y. Okay. All right, let's do number 3. What is happening here? Log of, everything is inside of the square root. So I'm just going to say everything raised to the half power, right? Square root is the same as the half power. So, and then I'm going to drop that half power in front of all the logarithm expression. So I get half times log of x cubed over yz. Good so far? There is other way of doing it. Like if you wanted to distribute that half here and here and here, you could have done it too. We're still going to get the same answer. All right, let's keep going. Over here, I'm just going to teach you a trick. If it's in the numerator of the argument, it's going to have a positive in the front. If it's in the denominator of the argument, it's going to have a negative in the front because that's a negative exponent. So you're going to do half log of x cubed minus half log of yz. Notice the negative. What can I do with that 3? I can drop that in the front. So it's going to be 3 half log of x Ooh, that y and z have a negative in the front, so I can distribute it. So negative half log of y minus half log of z. Make sure that negative half goes on both of them. So there's the answer. Okay? Alright, let's keep going. It says now condense it. We're going to combine it all together. I'm going to do number 5. So it's the other way that what we just did. Over here, we were like trying to expand it as much as possible, and then we're going to go backwards. So how would I do it? Just quickly. If you have any coefficient in front of the logarithm expression, you're going to piggyback right back as an exponent, and then write it as a root, and then condense it. So if you have any coefficient in front of the logarithm expression, keep that as the exponent. So log base 3 of x to the 1/3 power minus log base 3 of y to the 2nd power. And then what? Now let's combine them together. Both of them have log base 3. So the answer is going to have log base 3. X to the 1/3 power. What's the sign in the front? Positive. So it's going to go on the top. That one, what's the sign in front of it? Negative. So it's going to go at the bottom. Negative exponent. Now I can do one more step. Log base 3 of that 1/3 is the cube root of y and x and then y squared. This one right here, there is no coefficient in front of the natural log, so let's condense it all. Natural log of positive goes on top, negative goes at the bottom, and notice these are going to be multiplied here, right? Arguments are going to be multiplied. So natural log of, I can distribute it if I want, x squared plus 2x over x cubed. Oh, sorry. I can cancel out to get natural log of x plus 2 over x squared is the final answer there. Alright, almost there. Now let's use the inverse property on the next page. I'm going to number 8. Notice over here, well, the base is going to be, so using the inverse property, which was number, I guess that one isn't really an inverse property. That one's more of number 3 property. Oh well. I would like to take care of the exponents first. So natural log of base e to the cube root. So that becomes the exponent, right? Denominator of the exponent. So 2/3 there. And then now using property number 3, when your base and the bases are the same, I can just cancel it out. Answer 2/3. So you have to take care of those exponents first before you simplify it. Let's do number 10. There's exponent of 10. So I'm going to use the inverse property on this one. Do you remember this one, number 6? If I have a base and the base of the exponent is the same, I can kind of simplify like that. However, be careful on this one. I can't just get rid of those 10s and log 10 right away. Why not? Because of that 2. So I need to take care of that 2 first. How am I going to take care of that? Piggyback right back on top of the x. So I get 10 raised to log of x squared. And then using that property, it's going to be x squared. Inverse property. Number 11. I know you will be very tempted to just cross it all out. You can't. So you need to split this in half. Notice your exponents are adding. That means you're multiplying, right? So 5 squared times 5 to the log base 5 of x. What's 5 squared? 25. And then over here I can cancel it out. It's going to be x. So answer is actually going to be 25x. I know I rushed through a lot. If you feel like you still need a lot of practice, I highly encourage you doing those problems that we didn't go over with me, and then just look at the notes and try to figure out. Your IP is going to be, I think, everything, but double check on Haiku what it says. Okay? Great job today. Sorry my lessons are long, but your IP is not going to take that long. All right, good job, guys. Bye-bye.